Hello, this is Dr. Mears. Today we're going to be learning about normal curves, normal distributions, expected numbers, and we went over this in class, but some notes that should have been taken were the normal distribution curve, the location of the mean, which is in the middle. It is the center point. It's that halfway point. On either side of the mean was 1 or 2 or 3 standard deviations, so plus 1, plus 2, plus 3, minus 1, minus 2, and minus 3. And so mean, as I will repeat, is the middle center. It's the halfway point. The standard deviation measures how far a number is from the mean. So if you are 3 standard deviations, positive 3 standard deviations from the mean, that means you're way over here. So you're on the positive side of the mean, however, you're very far from it. If an observation lies negative 3 standard deviations, you're all the way on the other side, less than the mean. So if you have negative standard deviation, that means you're less. If you have positive standard deviation, then you're more than the mean. So it's all about the mean and whether you're greater than or less than and how far. If you're a positive 1 standard deviation, you are greater than the mean, but you're pretty close. You're here. So that's what standard deviations do. With these two numbers, mean and standard deviation, and a calculator, don't forget the calculator, we can find probabilities. We've been finding probabilities using Venn diagrams, tree diagrams, manipulation of rules. So this is yet another way that it can help us find a probability. We're also going to be talking about expected number today, and expected number is where you multiply the total number of observations by the probability. So those were just some quick notes I wanted to have on camera so that you have them. Okay, let's go. So you picked up this packet. It was the video normal curves and normal calculations. And we're going to go through it today. And I'm making sure that it's a little bit clearer for you here. Okay. Here's our example. On the driving range, Tiger Woods practices his swing with a particular club by hitting many, many balls. Suppose that when Tiger hits his driver, the distance the ball travels follows a normal distribution with mean 304 yards and standard deviation of 8. Sketch a normal distribution diagram to illustrate this information, indicating clearly the mean and the standard and the distances within 1, 2, and 3 standard deviations. So we have to draw that normal curve, and what we're going to do is we are going to fill the normal curve in with our numbers. So in the middle, as I said before, is always the mean, and the mean was 304. On either side is going to be plus 1 and minus 1 standard deviation. So before we can fill anything out, we actually have to calculate these. So here's how you calculate these. In order to calculate positive 1 standard deviation, what we're going to do is take the mean and we're going to add 1 standard deviation, which is 1 times 8. So it's going to be 304 plus 8, which is going to be 312. To calculate negative 1 standard deviation, we're going to take the mean and we're going to subtract 1 standard deviation, or negative 1 times 8. And so that's going to be 304 minus 8. And that comes out to 296. To calculate positive 2 standard deviations, we take the mean and we add positive 2 times 8, which is 304 plus 16, which is going to be 320. To find negative 2 standard deviations, we're going to keep going, just minus 2 now. So it'll be 304 minus 16, which gives us 288. Positive 3 standard deviations is 304 minus 3 times 8, which is 304 minus 24, which gives us 200, not minus, I'm sorry, positive, so we're going to add. So this is going to come out to 328. And on the flip side, now we get to do the minus 304 minus 3 standard deviations. So 304 minus 24, which is 280. So let's fill all this out. So positive 1 standard deviation and negative 1 standard deviation. So positive 1 standard deviation, we get 312. Negative 1 standard deviation, we got 296. Perfect. Let's go to 2. Negative 2. Positive 2 standard deviations, we got 320. Negative 2 standard deviations, we got 288. Let's go to 3. Negative 3. Positive 3 standard deviations, we got 328. Negative 3 standard deviations, we got 280. Labeling, Y-A-R-D-S. I want to know what you are measuring in, so yards, please. So please label yards, and that's how you fill out your normal curve. Okay, part B. What is the probability that the ball will land at 304 yards or less? What is the percentage of shots that the ball will land 304 yards or less? So first, let's tackle the probability, and then we'll do the percentage. So looking 304 yards or less. So that's right here. Here's 304 yards, and then less, we're talking about this half of the diagram, because remember, the mean is the halfway point. So if we were looking at this, here's my little diagram. Here's 304. We're just looking at that half. Let me bring it up close. Ooh, that half right there. So in order to calculate this standard deviation, you can think about it as, well, half the graph is 50% of it. Because what happens is this half and this half equal a whole. You're right. So actually the area underneath the curve is 1. You can also say it's 100%. Just like when we add the branches together, we got 1. The area underneath, the total, if we shaded this in, it's also equal to 1. So we know it's going to land about 50%. So let's use our calculator, and this is where you take your calculator sheets out and you follow along with the directions. So our calculator says in order to find less than, which is this shaded area over there, we're going to do a normal CDF, and we're going to put the numbers negative 90,000, comma. We put the number that they gave us, we call that the X. We put the mean, and then followed by the standard deviation. Please don't forget your commas. And so what that looks like, let me get my calculator quick. I will do this first one out. So you are going to be pushing second bars, which is down here next to the clear, and you push 2 for normal CDF, and that's what come up. Negative 90,123, comma, 304, comma, 304, which is the mean, comma, 8. Enter, and you get 0.5000. So IB likes 3 significant figures. So we are going to go, X is less than, we go 304 equals 0.500. That is the probability that the ball will land 304 yards or less. To find the percentage, you just simply multiply by 100 because percent is out of 100, and we find that 50% of the balls will land 304 yards or less. Awesome. Let's go to part C. What is the probability that the ball will land greater than 304 yards? Why is this answer the same? So now greater than, we said less than here was 50%, and if these two sides add up to 1, the other side is going to be 50%. So we actually answered, why is this answer the same? And that's because the mean is in the middle, so it breaks the graph up into 50-50. So with that being known, let's still use the calculator function. Probability X is going to be greater than 304. You're going to use your normal, equals. You still use normal CDF. However, what comes first, because it is greater than, is that X value. Then you put a positive 90,000, followed by the mean and standard deviation. Once you do that, this calculates out to 0.499999999, and that can approximate to 0.50, so we were correct. This is, again, 50%, which was the same answer as this, and that's because the mean is the middle number and splits the area of 1 in half. We got a 50-50 split. 50%, 50% split. Okay. What I would like you to do, knowing how to find a less than and a greater than problem, I would like you to do part D, which is this next one. Part E, right now on your own, pause it, see if you can do it, work the calculator. Coming back, we are going to be doing between, so that I can show you the between the two numbers. Here we go with between. So I'm going to do part F. What is the probability the ball will land between 296 and 312 yards? So we need the probability that the ball will land between 296 and 312 yards. It's still a normal CDF, but what you will notice is you put the low number then the high number, followed by, again, the mean and standard deviation. When you do that, it calculates out to 0.682. That is going to be your three significant figures. In a percentage, when you multiply it by 100, you do get 68.2% of the balls will land between that distance. Done. So I would like you to try the rest of them. I would like you to try G, H, I, and J. Please answer the questions after them, and please try to draw a picture. And when I talk about a picture, I'm talking about the normal curve and where it's going to land. So this would be more than 329. So here's our middle. So here's 329 all the way over here. So I would like you to draw a picture to actually answer the questions. And if you need help, call me over. I am going to provide you again with an answer key. So let's go on to expected number. Expected number is the total number of observations times the probability. So what's going to be given is a total number of observations. And with that total number of observations and the probability, we're going to be able to find the total number of balls that he hits that lands a certain distance, which is really nice. So let's read the example. Tiger Woods went out for practice one day and hit 125 golf balls. The distance the ball travels follows a normal distribution with mean of 304 yards and standard deviation of 8 yards. So same mean and standard deviation, but we know that he went out and his total number, N, of observations is 125. Let's do K. Find the expected number of balls that landed 304 yards or less. So this was the first example that we did finding probability, and that was X is less than or equal to 304. And if you remember, that probability was 0.50. And we found that 50%. So 50% of this will be 62.5 if we just divide it by 2. However, you can use it to get a calculator. You can just use it to get the probability. That's absolutely fine, but you have to get that probability first. So let's check if it's 62.5. So what you do to find your expected number, and I'm just going to do EN, you take the total number of observations and you multiply it by the probability that you found. This is what we found. And when you do that, guess what we get? 62.5 balls. Now, please, please, please give me the decimal. You can write it in a sentence. About 62 balls will land 304 yards or less. If you would like to round it, I would round down because he only hit halfway. He didn't hit 63, so do not round up. So round down, about 62 balls will land 304 yards or less. Give this answer, though. Give this answer on the line. Attach your units to it. So that was K. I would like to now go and do, let's see, which one? We did greater than 304. No, let's do more than 296. Let's do this one down here. So find the expected number of balls that landed more than 296 yards. Probability that X is going to be greater than 296. So you have to go, do the normal CDF, find your probability. If you just did the previous problems, you actually have that probability, and that probability came out, this was the previous problem here, greater than 296.841. So I'm just going to use the answer because we already did the work. So there's that probability, which is 0.841. To find the expected number, we're going to multiply 125, which is our total number of observations, times 0.841. And we are going to be getting 105.1. So our expected number of balls that will be hit more than 296 yards is 105.1 balls. Again, you can say about 105 balls will land more than 296 yards. Okay, the last one that I want to do is going to be the between. Find the expected number of balls that lands between, let's do O. Between 296 to 312 yards, because that's the one that I showed you how to do in the calculator just a second ago. So 296 is less than X, which is less than 312. So going back to find that probability, the between 296 and 312, 12 is going to be, where was it? Oh, 0.682. 0.682 we calculated. So to find the expected number, you take the total number of observations and multiply it by that probability. So our expected number of balls that are going to be landing there are going to be about 85.25 balls. So about 85 balls will land between 296 and 312 yards. And there you go, that's expected value. So you definitely need this total number of observations to do your expected value, and you do have to compute out your probability. So this has been normal curves, normal calculations, and expected values. I will provide an answer key with all of this, all of the answers on there for you, but I would like you to try it on your own right now and then do your DCCs. Thank you. Have a great day.